Welcome to the DX Today Expert Report. Today, we're diving into a pivotal moment in the technology landscape, one that is fundamentally redefining global enterprise computing. We are unpacking the recent Nvidia Gtc 2026 conference out of San Jose, which made one thing abundantly clear. The era of reactive AI, where we just type prompts into chat interfaces, is completely over. We have fully entered the epoch of autonomous, real-time agentic inference and physical AI.
That transition from large language model training to autonomous agentic inference is really the defining story of this year. Jensen Huang's 2-hour keynote at the SAP Center wasn't just another product launch. It felt like a line being drawn in the sand. Nvidia is no longer positioning itself merely as a chip manufacturer. They are essentially establishing themselves as the foundational operating system and infrastructure provider for the integration of the digital and physical worlds.
To truly understand the gravity of GTC 2026, we have to look at the historical context and the sheer speed of this innovation. This year marks the 20th anniversary of CUDA, the software platform that originally unlocked the parallel processing power of GPUs. But if we just look at the last 3 years, the architectural compression is staggering.
It really is. In 2023, we saw the Hopper architecture, which fueled the initial ChatGPT explosion. Then, as the industry shifted toward reasoning models in 2024, Nvidia brought out Blackwell. But the computational weight of massive mixture of experts models and continuous agentic reasoning created a massive bottleneck. The industry needed an even faster pivot, which brings us to the Vera Rubin platform, named after the pioneering astrophysicist.
The development cycle for Rubin is fascinating all on its own. Nvidia actually utilized its own Blackwell systems to accelerate the design of the Rubin architecture. That allowed them to compress the launch timeline dramatically, bringing Rubin into mass production for the second half of 2026. Jensen Huang called 2026 the absolute inflection point for inference, and the financial forecasts back that up entirely.
The financial implications they discussed are massive. We are seeing a fundamental shift in market dynamics, from training capex to inference capex. Over the last few years, the big spend was on training models, but now AI models are expected to think, reason, and execute multi-step workflows autonomously. They are doing tool calling, writing and executing SQL queries, and compiling code. The cost of running inference for those continuous workflows has skyrocketed.
Exactly, and that is exactly the problem the Vera Rubin platform is built to solve. It is explicitly designed to collapse those inference costs by up to 10 times. This is what will enable enterprises to scale agentic AI without destroying their unit economics. As a result, the hyperscalers and major cloud providers are treating AI servers and interconnected networks as long-term capital expenditures, on par with core cloud infrastructure.
Let's get into the hardware that makes that 10 times cost reduction possible, because the Vera Rubin architecture, specifically the NVL72 rack, represents a massive paradigm shift. We are moving away from single-chip dominance into true rack-scale supercomputing.
The silicon specifications alone are incredible. The Rubin GPU, the R200, uses a highly sophisticated multi-chip module design. It delivers 50 petaflops of FP4 inference performance per chip. But the memory bandwidth is where it really shines for these complex models. Each GPU features 288 gigabytes of HBM4 memory, delivering 22 terabytes per second of bandwidth. It is precision engineered to handle the incredibly dynamic memory access patterns required by mixture of experts architectures.
And when you scale that up to the standard deployment unit, the NVL72 rack, the numbers get even wilder. You have 72 Rubin GPUs and 36 Vera CPUs, all integrated via the NVLink 6 interconnect, which moves data at 3.6 terabytes per second. I want to highlight the Vera CPU here because it natively offers 3 times the memory bandwidth per core compared to traditional x86 CPUs. That is a critical detail. In agentic workflows, the AI has to execute tools, which is very heavy on the CPU side. Traditional CPUs were bottlenecking the GPUs, and the Vera CPU fundamentally solves that problem.
Of course, all of that raw power needs orchestration. Jensen Huang introduced the OpenClaw framework, which he boldly referred to as the operating system of agentic computers.
It is a massive step forward for software.
And for enterprises concerned about security, Nvidia launched OpenClaw alongside it. OpenClaw brings zero-trust security and network-level guardrails to open-source agentic workflows. When your AI agents are autonomously navigating your systems, you need absolute certainty that they are operating within strict boundaries.
They also announced the general availability of Dynamo 1.0, an AI inference software platform that acts as the core operating system across these massive AI factories. The whole software stack is optimized for ultra-fast agentic inference and real-time token generation, entirely eliminating the latency issues we used to see in complex agent chains.
While the Enterprise AI Factory was the main event, they did have something massive for the consumer and gaming sectors too. They unveiled DLSS 5. It is a huge leap in neural rendering and real-time graphics upscaling. It uses the exact same underlying AI advancements to generate hyper-realistic virtual worlds, securing Nvidia's dominance in the gaming space.
But building these hyper-realistic worlds and massive AI factories comes with incredible physical challenges. The power grid crisis was front and center at GTC. These AI factories require hundreds of gigawatts of power, making data center energy constraints the absolute primary bottleneck for the entire industry right now.
NVIDIA's response to that is the DSX Flex software. It is an energy management platform designed to transform AI factories into grid-flexible assets. Theoretically, this software can unlock up to 100 gigawatts of stranded grid power by intelligently managing compute loads based on real-time grid availability.
Beyond power, there's the thermal challenge. Traditional air cooling simply cannot handle the heat generated by the Rubin architecture. We saw industrial partners step up at the event, notably Mitsubishi Heavy Industries. They showcased next-generation high-efficiency liquid cooling and on-site power distribution systems that are required to keep the Rubin racks operational and prevent thermal throttling.
Then there is the challenge of data governance, which I think is one of the most critical hurdles for enterprises. When we talk about agentic AI, we have to talk about structured data. Data leaders at the event kept repeating that structured data is the ground truth of the AI era. If you have an AI agent autonomously executing SQL queries or modifying a database, the governance risks are immense.
Right. You can't just rely on simple network perimeters anymore. You have to establish a unified context graph to audit exactly which agents are accessing what data. The security burden has completely shifted to deep, granular data governance. If an agent hallucinates a destructive database command, the system needs to catch it instantly.
That real-world interaction brings us to what Jensen Huang called physical AI. This is the transition of AI out of the screen and into the physical environment. GTC 2026 highlighted several massive deployments, starting with the energy grid itself. Hitachi returned as a gold sponsor to showcase their HMAX physical AI solution.
The Hitachi deployment is a perfect example of digital and physical integration. They are using NVIDIA's Omniverse digital twin platform to combine live IoT data, high-fidelity 3D simulations, and AI-driven reasoning. By doing this, they managed to reduce critical interconnection study times for power grids by up to 80%. This directly helps utility companies future-proof transmission planning to handle the rising electricity demands of the very AI data centers we are talking about.
Another major theme was autonomous transport and robotics. NVIDIA officially declared this the ChatGPT moment for autonomous vehicles. They announced a huge partnership with Uber, planning to integrate NVIDIA-powered robotaxis into the ride-sharing network in select cities by 2027. We also saw expanded partnerships with BYD, Hyundai, and Nissan, all deploying NVIDIA's Alpamayo models for their self-driving fleets.
The robotics demonstrations were straight out of science fiction. Jensen Huang shared the stage with 110 physical robots. The one that went completely viral was the fully autonomous Disney Frozen Olaf droid. It was a brilliant way to showcase just how commercially viable and lifelike robotic articulation has become using their physical AI models.
It didn't stop at transportation and entertainment. Physical AI is heavily transforming healthcare and clinical research. Vicher announced a partnership with Stanford Labs to deploy upgraded Luma Ultra XR smart glasses running LabOS. This gives researchers hands-free, agent-guided clinical workflows right in the lab.
And in the operating room, Nvidia's healthcare robotics suite is making incredible strides. They train their systems on 776 hours of surgical video. At the conference, medical giants like Johnson & Johnson MedTech, Medtronic, and CMR Surgical confirmed they are adopting the Isaac GROOT models to assist in actual physical surgeries.
Looking at all of this, the roadmap NVIDIA laid out stretches deep into the late 2020s, and it goes far beyond Earth. One of the most futuristic announcements was regarding orbital data centers, or ODCs. NVIDIA is leveraging the Vera Rubin platform to spearhead AI computation in orbit. The goal is to process geospatial intelligence and autonomous space operations directly in the exosphere, rather than beaming all that raw data back down to Earth.
Back on the ground, they also mapped out the future of computing architecture by highlighting quantum computing synergies. Leaders from Pascal were at GTC, showcasing how they are bridging NVIDIA supercomputers with hybrid quantum classical systems. This is the next frontier for accelerating complex workflows like material science and drug discovery.
And NVIDIA isn't resting on the standard Rubin release. They have already confirmed the Rubin Ultra architecture for 2027. That system will connect 144 GPUs and double the performance to an astonishing 100 petaflops of FP4 inference. It guarantees that their hardware will stay ahead of the massive trillion-parameter AI models coming down the pipeline.
For the digital transformation leaders, CIOs, and CTOs listening to this breakdown, there are clear, immediate strategic directives coming out of GTC 2026. The first is that you must pivot your CapEx to inference infrastructure. Model training is no longer the primary bottleneck. Continuous agentic reasoning is. Organizations have to invest in inference-optimized architecture and factor in the massive cost reductions promised by Vera Rubin.
Secondly, software development teams need to adopt the OpenClaw agentic framework. As you transition to open-source agent frameworks, using OpenClaw ensures your corporate AI agents have enterprise-grade guardrails installed when they are interacting with your secure databases. You cannot afford a governance failure here.
That ties directly into auditing your data governance. Because these agents execute tasks autonomously, your data lakes must be highly structured and strictly governed. Utilizing tools like Atlan will be critical to ensure that agents are operating on verified ground truth and cannot execute unauthorized or destructive commands.
Finally, if you are in manufacturing, logistics, or robotics, you need to invest in physical AI data factories. NVIDIA open-sourced their physical AI data factory blueprint. You can use Cosmos 3 models to generate synthetic training data for your robots. This completely solves the traditional bottleneck of real-world data scarcity, allowing you to train physical AI systems much faster and safer.
Nvidia GTC 2026 will undoubtedly be remembered as the exact demarcation line where AI transitioned from a conversational novelty into an autonomous physical workforce. Jensen Huang's vision is executing flawlessly, as evidenced by the massive demand pipeline, the architectural breakthroughs of Vera Rubin and NVL72, and the real-world deployments in grid management, healthcare, and transportation. The tools to build the next decade of digital physical infrastructure are now in full production, and enterprise leaders must act decisively. Thank you for joining us on this deep dive on the DX Today Expert Report.